that phone call. You should already have equations written down in some notes there. You should already have it written down in some notes there. And in your notes, we have been solving these by inspection, which means basically just looking at them. You can take a great big fat marker pencil and cross that off because that no longer will be true. No longer will you be solving these things by inspection. Okay, you are going to have to actually write down some things in order to figure that out. And basically, the book says this. You are going to use what we call properties of equality. And we can sum those properties up in just kind of a simple couple words that basically say this. When you have an equation, you can add / subtract / multiply / divide both, and capitalize that both, and underline it twice, sides of the equation by the same number without changing it. And I'll tell you exactly what that means in a second here. Properties of equality. I bet you. Let's write down just any equation. By the way, equation just means it has to have an equal sign. If I had 24 equals 24, that is an equation, believe it or not. Okay, that is an equation. Basically, what this whole properties of equality thing, it just says this. As long as I do the same thing to both sides, I am still going to get an equal equation. In other words, let's say I just wanted to subtract 8 from both sides. As long as I do it to both sides, I still get an equal thing. Okay? And it doesn't matter what I do, whether it be adding, subtracting, multiplying, or dividing. Let's say I wanted to multiply both sides by 3. I will still get an equal thing 3 times both sides. As long as you do it to both sides. Okay? As long as you do it to both sides, you still get an equation. To which you might say is, so what? Well, here's the deal. When you have an equation like something like this, x plus 7 equals 329. Up until this time, you're just supposed to ask yourself, well, what number plus 7 is 329, and blah, 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 blah. No longer, this kind of takes the whole thinking out of it. Because when you find an equation, you have to remember your ultimate goal is you want to get the letter by itself. You want to get what we call the variable, which is the letter, by itself. On one side of the equal side. So here's the question you ask yourself. The letter x has his little friend here, Mr. plus 7 there. Okay, he wants to be, he's kind of a loner, wants to be by himself. Okay, you have to ask yourself, how do I get rid of a plusing 7, to put it in second grade terms? Well, to get rid of a plusing 7, you always think the opposite. The opposite of plusing a 7 is minusing a 7. And guess, what is 7 minus 7? Nothing. Look, Mr. X is by himself the way he wants it to be. However, ladies and gentlemen, I need to follow that rule I just set down. If I subtracted 7 from this side, I need to do the exact same thing from that side. Otherwise, it's not an equal equation anymore. So now if I just do my subtracting there, I get 322. And this, children, is what I need to see on your paper. We'll do thousands of them, so if you're slightly dazed and confused, don't worry. This was an addition equation. What if it was a subtraction equation? X minus 95 equals 428. Again, Mr. X over here wants to be by himself. So you have to think, how do I get rid of a minus 95? Think opposite. Opposite of minusing, opposite of subtracting is adding 95. Plusing is a good way to say it as well. A negative 95 and a plusing 95 gives you nothing. They go away. You're left with just this x. But the rule is, if you do it to one side, you have to do it to the other. So I have to add 95 over there as well. 5 plus 8 is 13. Boom, to 523. It takes that whole, well, let's cover this up and say, well, what number when I subtract 95 from it gives me 425? That would not be one that you really could do very well in your head. This is what I need to see minus these little extra marks by the x. What about this? What if it was 7 times x equals, I don't know, 147? Again, x wants to be by himself. He doesn't like this little 7 hanging on to him there, which means this is 7 times x equals 147. The opposite of multiplication is division. 7 divided by 7 gives you 1, and 1 is what you want because 1x and x are the same thing. And the same rule applies. If you divide this side by 7, you have to also divide that side by 7. As long as you divide, do the same thing on both sides, you're okay. You're left with x equals 21. And I suppose the one we haven't done yet is, I don't know if they give us much of this, but they might do this. X divided by 13 equals 26. How do you get rid of a dividing by 13? You multiply by 13, believe it or not, because if you do this, actually the 13's cross cancel. And then the same thing would be true here. Since I divided this, or multiplied this side by 13, I have to multiply 26 times 13, which is what, 18, 78, 26, 338 maybe? Something like that. It very much takes out all of the guesswork that you're going to do for all of this stuff here. Now, there are a couple things we also need to talk about in that this. What happens if you see this? Now, please listen carefully to this, because I will tell you this probably 732 times in the next year or so and a half. Okay, we can go through the long process of this. Okay, first of all, what type of an equation is this? This is a multiplication. 3/5 times x equals that. So to undo multiplication, you divide. Well, I'm dividing by 3/5, but how do you divide by fractions? You flip and multiply. So rather than going through all those steps in your head, just remember this. If there is a fraction in front of the letter or the variable, comma, you just flip and multiply by that fraction, because that's what division is. But rather than think about all those different things you'd have to do, so it will look like this. To get rid of this, I multiply by that fraction flipped over. And whatever I do to one side, I have to do to the other, so I multiply the same thing on the other side. These 5's cross off, these 3's cross off, and you're left with just the x. And then this would actually cross cancel as well, and you're left with 1/3. Comes up all the time. Fraction in front of a letter, you're going to flip and multiply. Flip and multiply. Alright, let's look at some more, because I know you're not ready for the place on the road. So how about this one? X plus 1/2 equals 3/4. Want to get x by itself? You think about what type of an equation it is, because you're going to do the opposite to solve it. I have to get rid of that 1/2. How am I going to get rid of 1/2? Carol Winkman? Nope, if I add another half, I'll get 1. What's the opposite of adding, huh?
By subtracting.
By subtracting a half. See, if this is plus, you are going to minus to get rid of it. Half minus a half goes away. But what I do to this side, I have to do to that side, so I subtract a half from this, which means I change to common denominators. 3/4 minus 2/4 is 1/4. What about this one, ladies and gentlemen? How about x minus 1.3 equals 4.2? How am I going to solve that equation, Brianna Massey? Yep, you need to get rid of a minusing, a subtracting 1.3, so you do the opposite and add 1.3, and you add 1.3 to both sides. This goes away, you're left with x. Add those together, it is 5.5. God bless you. Has faith in my head. Oh, and I suppose we should do one more. What if they gave you this equation? T, we'll change letters up. T plus 5 equals 2. How do I get the letter T by itself? Elijah Pitcher? Subtracting 5. And here's where you have to be a little careful. My T's by itself. What is 2 minus 5? Lucky you can work with positive and negative integers now. Kate?
-3.
Very good, -3. You have to be careful not always with your answers. Be positive. Not always with it.